Hello, here's Chapter 5 Test Review, Part 2. So in question 7, it says evaluate the integral using u substitution. So just by looking at the integral 2x square root of 3x squared minus 1 dx, you should be able to notice that you need to take the u substitution. This is a more complicated integral where we can't just take the integral of each one. Here we're going to have to do u substitution. So the idea of u substitution is to take something that's more complicated and turn it into something that's simpler to take the integral of using u substitution. So in this case, we're going to make u 3x squared minus 1. Now, how do we know which part of the equation or which part of this to make u? Well, two things. Number one, u should make the problem simpler, and then taking the derivative should make the problem simpler. So for example, I'm not sure how to take the integral of 3x squared minus 1, but if I make that the integral of square root of u, then that would be easier to deal with than taking the integral of square root of 3x squared minus 1. Number two, once you take u, which is 3x squared minus 1, we take the derivative of u with respect to x. So the derivative of 3x squared is 6x, and the derivative of minus 1 is 0. Then, since we look at the original, we're going to substitute in. There's no du over dx. We're going to solve to get dx. So we can think of this as a proportion. Du over dx equals 6x over 1. Cross multiply, dx times 6x equals du times 1. Then to get dx by itself, we divide both sides by 6x. So dx times 6x divided by 6x, du divided by 6x gives us dx equals du over 6x. Now just a little shortcut, to go from du over dx equals 6x, we can go directly to dx equals du over 6x. It's always going to be dx equals du over the derivative because of the proportion we just discussed. So if you look at the derivative, 6x, that's also going to help us simplify because we have this 2x, and the 6x will be in the denominator. They will simplify. So once we go through this problem, we'll see how it simplifies. So we have the integral of 2x square root of 3x minus 1 dx. Instead of 3x squared, we're going to put 1. And instead of dx, we're going to put du over 6x. Once we do those substitutions, we have the integral of 2x square root of u times du over 6x, which looks more complicated, but if we take a second look, it actually simplifies pretty well. So taking the integral, and then we have 2x divided by 6x, which gives us the x divided by x is 1, so it simplifies out. 2 divided by 6 is 1/3. We could rewrite the square root of u as u to the 1/2 du. We haven't taken the integral yet, but we have been able to simplify the integral of 2x square root of 3x minus 1 dx to integral of 1/3 u to the 1/2 du. That's the point of u substitution. Now, we haven't taken the integral yet, we can take the integral. So the 1/3 stays in front. The integral of u to the 1/2, add 1, 1.5, divide by 1.5, plus c. 3 times 1.5 is 4.5 in the denominator, so we have 1 divided by 4.5, which simplifies to 2 over 9. U to the 1.5 plus c. But we don't want our final answer in terms of u, we want to go back to x. So remember, u equals 3x squared minus 1, so our final answer would be 2 over 9. Instead of u, we put 3x squared minus 1, raised to the 1.5 plus c, so our final answer is 2 over 9, parenthesis 3x squared minus 1 close parenthesis raised to the 1.5 plus c. And that will help us out for the other ones that we're going to use substitution for. So for question 8, we have the integral of x plus 1 times e raised to the negative x squared minus 2x dx. So again, we need to decide which is u. U is going to be negative x squared minus 2x because it will make it simpler. Instead of e to the negative x squared plus minus 2x, we'll have e to the u, much easier to take the integral. And the derivative, du over dx equals derivative of negative x squared is negative 2x. Derivative of negative minus 2x is negative 2. Remember the little shortcut, dx will equal du over the derivative, which is negative 2x minus 2. And then we can factor out a negative 2 here, which will help us out a little bit later. So we have dx equals du over negative 2 times x plus 1. Notice the x plus 1 in the original, and this will have x plus 1 in the denominator. Hopefully you can see where we're going with this. So when we do our substitutions, we have the integral of x plus 1 times e to the negative x squared minus 2x dx. Instead of negative x squared minus 2x, we put u. Instead of dx, we put du over negative 2 times x plus 1. Then we have integral of parenthesis x plus 1 close parenthesis e to the u times du over negative 2 open parenthesis x plus 1 close parenthesis. Notice the x plus 1 and the x plus 1 in the denominator will simplify to 1, so that disappears because it turns to 1. And we have the integral. Now the negative 2 is in the denominator, so it will be negative 1 over 2 e to the u du. Again, we haven't taken the integral, but we made something more complicated. Integral of x plus 1 e to the negative x squared minus 2x dx into integral of negative 1/2 e to the u du. Now we can take the integral. So the negative 1/2 stays in front. The integral of e to the u is e to the u. Don't forget your plus c. And we don't want our final answer in u, so we have negative 2x e. Instead of u, we put negative x squared minus 2x plus c. So our final answer is negative 1/2 e to the negative x squared minus 2x plus c. Question 9. Another u substitution problem. Again, by looking at it, we can see that it is a more complicated problem because we have the integral of, in the numerator, x squared plus 5x plus x to the 5th. And the denominator, we have square root of 2x cubed plus x to the 6th minus 5 dx. So again, complicated integral. With u substitution, we can simplify it and hopefully make it easier. So we have to decide what our u is going to be, and u will be 2x cubed plus x to the 6th minus 5. Two reasons. Number one, we don't know how to take the integral of square root of 2x cubed plus x to the 6th minus 5, but if we make all that u, 2x cubed plus x to the 6th minus 5 into u, then we'll have square root of u, and it's much easier to deal with. And then when we take the the derivative of u equals 2x cubed plus x to the 6th minus 5, du over dx, the derivative of 2x cubed is 6x squared, the derivative of x to the 6th is 6x to the 5th, and the derivative of minus 5 is 0. Then remember our shortcut, we have dx equals du over 6x squared plus 6x to the 5th. And then to kind of look ahead, we're going to factor out the 6 in the denominator to give us dx equals du over 6 times x squared plus x to the 5th. So our original is integral of x squared plus x to the 5th all over square root of 2x cubed plus x to the 6th minus 5 dx. Then when we do our substitutions, instead of 2x cubed plus x to the 6th minus 5, we put u. Instead of dx, we put du over 6 times x squared plus x to the 5th. So we'll have the integral of x squared plus x to the 5th over square root of u times du over 6 times x squared plus x to the 5th. And you'll notice that x squared plus x to the 5th in the numerator and x squared plus x to the 5th in the denominator will simplify to 1. So we'll have the integral of 1 over 6. We have the square root of u in the denominator, which is u to the 1/2. When it moves up, it will be u to the negative 1/2. So we have the integral of 1 over 6, u to the negative 1/2 du. Haven't taken the integral yet, but we've made it much simpler to deal with. So the 1 over 6 stays in front. Add 1, negative 1/2 plus 1 is 1/2, divide by 1/2. 6 times 1/2 is 3 in the denominator, so we have 1/3, u to the 1/2 plus c. We don't want it in terms of u, so where there's a u, we're going to put 2x cubed plus x to the 6th minus 5. So we have our final answer of 1/3, parenthesis 2x cubed plus x to the 6th minus 5, close parenthesis the 1/2 plus c, or that can be written as 1/3 square root of 2x to the 3rd plus x to the 6th minus 5 plus c. And the next example, notice we have a definite integral. That means we have bounds. So it's the integral of 1 to 5, x to the 4 minus 6x cubed plus 5x minus 1 over x squared. So we're going to take the integral, then we'll substitute the numbers in, and then I'll show you how to check that in the calculator. So for number 10, the integral of x to the 4 minus x cubed plus 5x minus x to the negative 2 dx, the integral of x to the 4 will be x to the 5 over 5. The integral of minus 6x to the 3rd will be minus 6x to the 4 over 4. The integral of plus 5x will be plus 5x squared over 2. And the integral of minus x to the negative 2 would be minus x to the negative 1 over negative 1. Then we're going to go from 1 to 5. But we'd like to simplify first, make this a little bit easier. So x to the 5th over 5 would be 1/5 x to the 5th minus 6x to the 4 over 4. 6 over 4 would be 3 over 2 x to the 4. and 5x squared over 2 be 5 plus 5 over 2x squared, and minus x to the negative 1 over negative 1, negative over negative is positive, 1 over x from 5 to 1. Then we're going to plug 5 into the x, minus plug in 1 into the x. So we plug 5 in first, so we have bracket 1/5 x to the 5th, minus 3/2 5x to the 4th, plus 5 over 2, 5 squared, plus 1 over 5. Again, everywhere there's an x, we put a 5. Minus, then we plug in 1 everywhere there's an x. So it's bracket 1 over 5 times 1 to the 5th, minus 3 over 2, 1 raised to the 4, plus 5 over 2 times 1 squared, plus 1 over 1. On the left side, if we plug in 1/5 5 to the 5th, minus 3/2 5 to the 4th, plus 5/2 times 5 squared, plus 1 over 5, we get negative 249.8. Minus, if we plug in 1/5 1 to the 5th, minus 3 over 2 1 to the 4th, plus 5 squared, 5 over 2, times 1 squared, plus 1 over 1, that's going to be minus 2 over 2. And negative 249.8 minus 2.2 gives you negative 252. So if we want to check this in the calculator, what we can do is plug in the original into the calculator. So we can go to Math, go down to number 9. And again, we could check this because we have a definite integral. This is going from 1 to 5, and we type in the original. So on the lower we put 1, upper we put 5, and then we move to the right, and this will be x raised to the 4 minus 6x raised to the 3rd plus 5x minus, and since we have a fraction, I'll put in parentheses 1 divided by x squared, close the parenthesis, press enter, and before we press enter, we'll get an error if we push enter too soon. Before we push enter, make sure we have an x at the end. X. Push enter, and that will give us negative 252, which matches our answer by hand of negative 252.